Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be taking a look at an example that involves calculating the area of a sector and also making use of the circle, arc, and angle theorems. The question reads, in the diagram below of circle O, tangent AB is drawn from the external point B and secant BCOE and the diameter AOD are drawn. Question, if measure of OBA is 36 degrees and OC is 10, what is the area of the shaded sector DOE? Okay, so we need to find the area of this shaded sector right here. Okay, so to get us started, we're going to take a look at a theorem that connects tangent lines and angles. It goes through the center of the circle to the angle that is formed by the tangent line and that segment. All right. So if you take a look at this diagram that we have right here, this is a tangent line AB. Okay. You have a tangent line. Now, if you have a tangent line to a circle and another segment that goes through the point of tangency right through the center of the circle, okay, it could be to the center or through the center. In this case, it goes through. It doesn't really matter. It doesn't make a difference. Guess what? The angle formed is always what? The angle formed is always 90 degrees. So this angle right here is going to be 90 degrees. Okay? All right, so let's go ahead and note down that important point. All right, so since segment AB is tangent to circle O, and AD goes through the center of circle O, right? Then the measure of angle A is 90 degrees. Bam, okay? So this is 90 degrees right here. Okay, we're also told that OBA is 36 degrees. So this is 36 degrees. Ladies and gentlemen, in order for us to find the area of this sector right here, we need to know this angle. Let's call it theta, all right? So we need to find this angle right here. We can call it theta. If we can find this angle, then we can use the area of a sector formula to figure this out. Okay, so in order to find this angle, theta is a vertical angle with this. So this is also theta, right? Now, how can we find out what theta is? Well, we have a triangle with two angles, so we can easily find a third one using the triangle angle sum theorem, right? So let's go ahead and write down the formula so we know that the measure of angle A plus the measure of angle B, or we can also call it measure of angle OBA, plus the measure of angle AOC, which is theta, is equal to 180 degrees. All right, we know this because of the triangle angle sum theorem. It tells us that the sum of angles in a triangle is 180 degrees. If you need to review your theorems for geometry, do visit our website at mathgotserved.com. You can gain access to all the formulas, theorems, vocab, and postulates that you need to know to understand this problem. Okay? All right, so let's go ahead and substitute. So measure of angle A is 90 degrees plus OBA is 36 plus measure of angle AOC is 180 degrees. All right, so this is an algebraic equation. We can just solve this. 90 plus 36 is 126 plus measure of angle AOC is 180. So we subtract 126 from both sides of the equation. That will leave us with the measure of angle AOC. Okay, so that clearly shows us that the measure of angle AOC is 120. Oh, sorry, it's not 126. 180 minus 126 is 54, so it's 54 degrees. Bam. All right. Now, as indicated earlier, this theta right here, angle EOD, is equal to angle AOC. So the measure of angle EOD is equal to the measure of angle AOC. You remember the reason why these two angles are congruent, this one and this one? They are vertical angles. All right, so let's go ahead and specify that. They're vertical angles. All right, so we know the measure of angle EOD is also going to be 54 degrees. Okay, now we're going to advance to the final part, which is the area of the sector. So to do that, we need a formula. So the area of a sector is given by A equals theta, the angle of the sector is equal to theta over 360 times pi r squared. Okay, so you're just taking the area of a circle and you're dividing it by the ratio using that angle, multiplying it by the ratio. Okay, all right, so in this particular situation, we know that theta is 54 degrees, right? Because this is 54 right here, and it's vertical angles with this one, so this is also 54. So our area is going to be 54 divided by 360. Okay, that's a fraction of the angle that this particular area occupies, and then multiply that by the area of the circle, pi times the radius OC. So you're told that OC is 10, right? So this segment right here is the radius, is 10, and is also the radius. Okay, so times 10 quantity square. So all you just do is please excuse my Dan Sally, to simplify this. Okay. All right, so we have 54 over 360 times pi times 100. All right, 16 goes into 54 and 360. Right, I mean 18, right? So we're gonna divide top and bottom by 18. Okay, just to reduce it, so divide by 18, divide that by 18, divide that by 18. Upon carrying out that reduction, we're going to have 54 divided by 18 is 3, over 360 divided by 18 is 20, times, let's put the number first, 100 pi. Okay, so let's see, what can we do here? We can divide by 20. So 20 goes here once, and 20 goes here 5 times. And then 5 times pi times 3 will give us 15 pi, right? So our area of shaded sector DOE is going to be 15 pi square units. The answer is option number 4. Okay, so there you have it. Thanks so much for taking the time to watch this presentation. Don't forget to help support our channel by interacting with this video. Tons of support resources can be found at mathgotserved.com. Do check it out. If you have any questions about this tutorial or any geometry concepts in general, specify it in the comment section below. We'll be more than glad to support you. Thanks again for watching. We'll see you in the next video. Goodbye.